See this sine x over cosine x? That's my numerator. And I'm dividing all that by sine x. Well, instead of dividing by sine x, let's do this. Sine x divided by cosine x times 1 over sine x. We can do that. That's okay, that's acceptable. Instead of dividing by sine x, multiply by 1 over sine x. That is the same thing. Dividing by something is the same thing as multiplying by that same fraction. So dividing by 2 is like multiplying by a half. Okay? Sine x and sine x are now kind of easy to see here. These can cancel out. And I'm left with 1 over cosine x. Which, lo and behold, my basic 8, 1 over cosine is secant. Who would have thought this actually worked out? Secant x equals secant x. I really like proving stuff because it's kind of like a puzzle. This side equals this side. How? Show it. Figure the puzzle out. Navigate the maze. That maze. That corn. Hey, save me a piece of that corn for later. Number 8. Turn to the back. Toying to the back. Which side are we working with again? We are working with the left because that's what the directions have told us. Work with the left. For today, you will always work with the left. I will let you know when you can work with the right. Tan x plus cotan x equals cosecant x secant x. Ooh, this is going to be fun. Okay. For starters, we've got tangent x, which I know is sine x over cosine x, plus cotangent, which is cosine x over sine x, equals CSCX, SECX. Ding, 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 and sine x over cosine x plus cosine x over sine x. Now we've got two fractions here that I need to do something with. Two fractions I need to do something with. Well, I'm adding two fractions together. And forget the precal for a moment. I know that anytime I add two fractions together, I need common denominators. Common denominators. So here's what I'm going to do. How do I get common denominators? Multiply each fraction by what it is missing from the other. So for example, cosine x is missing sine x from the bottom over here. So I'm going to multiply by sine x over sine x. And on this side, I am missing cosine x. So I'm going to multiply cosine x by cosine x. And let's see what becomes of us. We have sine times sine. Well, I know that sine times sine is sine squared. Sine square x plus cosine times cosine is cosine square x. All over. My denominator now, sine x cosine x. Sine x cosine x. Now you may be saying, but Mr. Ballard, we added sine x plus sine x. Shouldn't that be 2 sine x cosine x? No. You know better than that. If I take 1/3 plus 1/3, that's not going to give me 2/6. You know that's not the case. 1/3 plus 1/3 is 2/3. You don't add denominators. You know better than that. You just put them all over themselves. Equals CSCX SECX. Okay. Now this is where it actually gets interesting. Because we've got sine x plus cosine x. And If I'd be doggone, I don't tell you what, sine x, or sine squared, wait, sine squared x, cosine squared x, that's what I meant. Sine squared plus cosine squared equals 1. My Lanta. Sine x plus cosine, sine squared plus cosine squared. That's all 1 over sine x cosine x equals CSCX SECX. Getting close. Cool. Well, this is sine x times cosine x, right? But what if I wanted to flip them? Let me ask you this. Before I get any farther, I want you to tell me, and don't just assume they are because I may be playing a trick on you. Is this 1 over sine x cosine x the same thing as this? Pause the video, catch up. Are these two things the same? 1 over sine x cosine x. Is that the same as 1 over sine x times 1 over cosine x? Well, yeah. You're just flipping the, or you're not flipping, sorry. You're splitting the fractions. Yeah, those are the same. Okay? Okay. 1 over sine x. Well, go back to your basic 8 and you got that's cosecant x. 1 over cosine x, go back to your basic 8 and that's secant x. Isn't that cosecant x, secant x? Doggone tell you what. Yippee-ki-yay. That's what I'm talking about. That's a trig proof. It wasn't too hard. Was it? No, Mr. Ballard, it wasn't too hard at all. I know. Now let's go to number 9. Now number 9 has the possibility of getting out of hand. Do not freak out. Remember, you are not touching the right side. Not yet. You will later. But you ain't going to touch that right side right now. Don't you touch that right side right now. Okay? Okay. Let's go to number 9. Now number 9, the first thing I see when I'm on the left, it's 1 plus tangent x squared. Meaning that square means there's 1 plus tangent x times 1 plus tangent x right here. Right? So the first thing I'm going to do is multiply them guys out. Forget cosine for a second. Multiply these guys out. So I'm going to save you some time here. I'm going to save you some time. It's going to be 1 plus 2 tan x plus tan squared x. And put that guy in parentheses. Again, this is 1 plus tangent x times 1 plus tangent x, right? If you need to see where that came from. One times 1 is 1. 1 times tangent. 1 times tangent, that's 2 tangent x. Tangent times tangent is tangent squared. Times cosine squared x. I always bring the right side down. I know it may seem just like you're writing it redundantly because it's all going to be the same on the right, but it always helps just kind of always keep looking back to what you're supposed to be going to. Okay? Now, let's multiply this cosine through. So this will be cosine squared x plus 2 tan x cos x plus tan squared. Oh, wow, wait, cosine squared. Missed that cosine, didn't I? Plus tan squared x cos squared x equals 1 plus 2 sine x cosine x. Now you may be saying to yourself, But Mr. Ballard, there ain't nothing there going to simplify. And I would say, nay, nay. Or you just need to be creative. Tangent x. If all else fails, change everything to sine and cosine. I know I'm going to have to do that anyway from looking at my answer. But if all else fails, change everything to sine and cosine. So wouldn't this be cosine squared x plus 2 times, tangent is sine x over cosine x, cosine squared x plus sine squared x, cosine squared x. I'm changing tangent squared to sine squared over cosine squared. Cosine squared x equals 1 plus 2 sine x cosine x. Oh, we're going to simplify here. Yes, we are. We're going to simplify. Check this out. Cosine x and one of these cosine x's is gone. That's not a 3. That's a gone. Cosine squared x and cosine squared x, gone. Write down what you got left. Cosine squared x plus, 2 sine x cosine x plus sine squared x, 1 plus 2 sine x cosine x. Write that down. And lo and behold, class, 2 sine x cosine x, 2 sine x cosine x, they're here. We're there. How do we get the 1? Where in the world does that come from? The basic 8 identities, Mr. Ballard. Oh, I'm so glad you were here to help. The basic 8 identity. What is sine squared plus cosine squared? Or cosine squared plus sine squared? What? You're telling me these dudes right here, these dudes come out to give you 1 plus 2 sine x cosine x equals 1 plus 2 sine x cosine x? Proved. What do you think? Another 27-minute. Man, I'm on a roll today. All right, make sure you keep your basic 8 identities handy. We'll be doing a lot more proofs in class. I'm going to give you a few tips and tricks along the way. So let's come class ready to go.